So a second example of being able to utilize the chi-square test to be able to do one of these types where we determine if a sample proportion is the same as a population proportion distribution. In the year 2000, census reported that the following proportions of U.S. residents and when they reside. In 2015, a random study of U.S. residents asked, where do you currently reside? And below are the results. Is there evidence to suggest that the 2015 survey distribution is different than the population study done in 2000, tested the 10% significance level? The null hypothesis assumes that if people just stay in the same region year to year, then there would be no significant difference in the distribution. So H sub naught, we're going to say that there is no significant difference in the proportion of the population, residents, and the sample residents. And of course the alternative would be the exact same thing, except that there is a significant difference. Okay, so we're just going to copy that, and we're going to say there is a significant difference. All right, variables, pretty easy to get. So we know that K is going to be the easiest one, and K in this case is going to be equal to 4 because there's four possible categories. So 1, 2, 3, 4 of those. N is not told to us, but for us to get N, all we're going to have to do is just add up all of the samples that are given. Okay, so N is going to be 900 plus 1089 plus 1846 plus 1165. All right. And I'm going to stick that in my calculator. And I end up with 5,004. It's an odd number. Let me check that again just to make sure I didn't make a mistake. $5,000. Okay. All right. The significance level that's given, very easy to find, is going to be 10%. And then finally we can find the critical value and then construct the distribution. So chi-square critical is going to be based on 3 degrees of freedom. So that's 4 minus 1, which is 3. And then alpha, which is 10%. Right? And we're just going to go down to our table. All right, so in our table, we have 10% significance, and then we have 3 degrees of freedom, and we end up with 6.251. So we're going to construct the distribution. Remember, chi-square distribution, skewed to the right. There's more data on the left. It's always a right tail test no matter what. And so we have 6.251. See if I can squeeze the 2 in there. There we go. And remember, the range of values goes from 0 to positive infinity. All right. So now we have to go through and compute the test statistic. All right. So I'm going to copy the table so that way I don't have to keep looking back and forth. Okay, so copy this guy. All right. Now remember, what's given is the expected values. All right. So we're going to make 2 columns to start. We're going to have, what's given is the observed values. So O is the observed values, and those are going to be 900, 1089, 1846, and then 1165. The expected values are computed by N times P, and we know that N is 5,000, and P is going to be each of the sample proportions. Okay, so we're going to go back up, and we're going to have, first of all, 0.19 times 5,000. Okay, so this is going to be 0.19 times 5,000. And then we just keep going back up, and we're going to multiply by 22.9 or 0.229, 0.356, and then I think it was 227 or 225. and we're going to multiply each of those by 5,000. Sorry. Alright, so we'll type these in our calculators. Alright, and if you could check along with me just to make sure I didn't make any mistakes. First one's 950. Second one, 1145. Third one, 1780. And then finally, 1125. Next column, O minus E. So all we're going to do is we're just going to take these two columns, the O and the E column, and we're going to subtract those. All right, so the first one is negative 50. 1089 minus 1145, negative 56. 1846 minus 1780, 66. And then finally, 1165 minus 1125, that should be 40. All right. Now remember, a way to check at this point is to take the sum of all four of those values, and I'm just adding them up. It looks like it's going to end up being 0, which it is. All right, so that's a good way for you to make sure you're on the right track. If those don't add up to 0, then you're definitely on the wrong track and you need to go back and recompute. All right, so next row, O minus E squared. So we're going to square each of the values that we just got. So 20 or 50 squared is going to be 2,500. And remember, when you square a negative number, it always goes positive. Negative 56 squared is 3136. 66 squared is 4356. And then finally 40 squared is 1600. And then finally, to finish off our chart, the last column we need is O minus E squared divided by E. All right, so if we go through and do that, the first one, I'll just write the first one out. That'll be 2,500. And we're going to divide that by the first E, which was 950. And we end up with 0.2632. So 2.632. And then for the next one, we're going to take 3136 and we're going to divide that by 1145. So that gives us 2.739. And then 4356 divided by 1780. And that's 2.447. And then finally 1600 divided by 1125, and that gives us 1.422. All right. Last thing we do, we take the sum of all those numbers, and that's going to give us the chi-square value, the test statistic. All right, so 632, 2.739, 2.447, 1.422, and I end up with 9.24 as the test statistic. So, last thing we're going to do, we're going to plot it on the distribution and come up with a conclusion. So we go all the way back up. 6.251 was the critical value, and then 9.24 clearly is bigger than 6.251. That's our chi-square test statistic. And what we can say is that there is indeed significant evidence to suggest that the proportions are not the same from the population to the sample. All right, so let's just type that out just so we have a conclusion. So we are going to say that since the test value falls in the reject region, we reject the null, hence there is significant evidence or there is a significant difference, or there is evidence to suggest that there is a significant difference in the proportion of the population residents and the sample residents. Okay. All right. So before you move on to the next set of videos, which talks about the other two types of chi-square tests, I would make sure that you're all okay being able to do this type.